Unit 2, Lesson 3, Transformations, Part 1. So a review of quadratic transformations. This should be learned in grade 10. So remember that the base graph of a quadratic is y equals x squared, and then we add all these other pieces to it in order to transform it. So let's review what all those pieces represent. A represents a vertical compression or stretch, and if your A value is positive, then your parabola opens up. So your parabola is going to look like this, okay? If that A value out in front is negative, your parabola is going to open down. So it's going to open this way. Let's look at the absolute value of A. So ignore if it's positive or negative. Let's just look at the number that A is, okay? So if A is a positive whole number, that means that the parabola is going to be vertically stretched, okay? So the parabola is vertically stretched if A is greater than 1. So that just means if you have a parabola like this and you held on to both those arrows and stretched them up, it's going to get skinnier. Okay, so that's kind of what a vertical stretch does in terms of how the graph looks. Now, if A is less than 1, so if the A value is a fraction, that means that the parabola gets vertically compressed. Okay, so if A is less than 1, it's a vertical compression. So if we start out here, and then if you were to put your hands on those arrows and push them down, you're compressing that parabola. It's going to get fatter, so it's going to look like this. Okay, so that's kind of what a compression does. Okay, so this p-value represents a horizontal translation. So it moves the graph left or right. Okay, but remember it's the opposite. So if it's a negative value, you actually move to the right. Positive means move to the left. Where there's a negative sign in the bracket, parabola is translated to the right. Okay, and if p is negative 5, you go to the right 5. If there is a positive sign in the bracket, so if your p-value is positive, the graph is moved to the left. So if it's x plus 7, you go to the left 7 units. Finally, our q value is a vertical translation. So that q value tells you if you are to move the parabola up or down. So if the q value is positive, you move the parabola up however many units q is. So if q is plus 5, you would move the parabola up 5. Okay? If the value of q is negative, the parabola moves down. So if q was negative 7, you would move down 7 units. Okay, so I have some steps for how to graph the translation of a quadratic. First thing you want to do is apply your vertical stretches or compressions. Then you want to add in any reflections, and finally you want to apply your vertical and horizontal shifts. So I'm going to show you how to do all that now. So for question 1, we're dealing with this graph. Okay, they want us to graph that. It is a quadratic, so the base graph associated with a quadratic is just y equals x squared. Okay, so let's describe all the transformations that are happening to this base graph in order to get that. Okay, so first we have a vertical stretch of 2. Okay, then we have a horizontal translation to the left 5 units. And finally, we have a vertical translation down 3 units. Okay, so let's go ahead and graph it. So first thing you always want to do is graph your base graph. So just graph y equals x squared, and then apply all those transformations that we just listed to it. Okay, so if you're not sure what y equals x squared looks like, make a table of values. So when x is negative 2, your y value is going to be 4. I just plugged it in for x. Okay, fill that in. And you'll memorize this because you're going to do this a lot. Okay, so let's plot all those points. Okay, so this was our base graph. Now we need to go ahead and apply those 3 transformations to them. So first you want to apply your vertical stretch of 2. So to do that, you're going to multiply all the y values by 2. So I'll show you what I mean by that. So you always want to set up a table of values in order to keep this organized. So now instead of it being y equals x squared, we are going to have y equals 2x squared. Okay, so we basically just take all our values here and multiply them by 2. Okay, and now let's graph these points. Okay, so this red graph has had the vertical stretch applied to it. So it's now y equals 2x squared. Okay, so we've done the vertical stretch. So I'm going to take each point, go to the left 5 and down 3. So now that blue graph has everything applied to it, right? That blue graph has been stretched by 2. It's been translated to the left 5 and down 3. Okay, so let's state the domain of that blue graph. So because it's a quadratic, the domain is going to be x is an element of all the real numbers, and there's no restrictions here. The range is going to be y is an element of all the real numbers, but there's going to be a restriction. So as you can see, the vertex is right here at -5 and -3, and our quadratic is opening up. So our restriction is such that y cannot be any value less than -3, because there's no points below here. Okay, example 2. Again, we have a quadratic. Okay, let's state the transformations that have been applied to our base graph in order to get the given quadratic. So we have a p-value of -3. So the only transformation that's been applied to our base graph is a horizontal translation to the right 3 units. Okay, now let's graph it. So remember, when graphing, you always graph your base graph first. So x and y equals x squared. Okay, now we need to translate this to the right 3. So I'm going to take every point and move it 3 to the right. Okay, so there's our final graph of y equals x minus 3 squared. And now let's state the domain and range. So because this is a quadratic, the domain is going to be x equals an element of all the real numbers, and the range is going to be any y value greater or equal to 0. Okay, let's describe the transformations that have been applied to the following quadratic. So first, we have a reflection about the x-axis. We have a horizontal translation to the left 3. And we have a vertical translation up 2. Okay, let's go ahead and graph it. So we have our base graph. By now you might have memorized how to draw that. Okay. Now if we had a vertical compression or stretch, I would want you to draw the table of values and go through it that way. But because we only have a reflection, we can go ahead and do that quite easily without a table of values. Okay, and now we're going to take each of the points on that blue graph and move them to the left 7 and up 2. So this is our completely transformed graph. So now let's state our restrictions. So the domain is an element of all the real numbers. The range is any value of y less than or equal to y equals 2. Okay, our final example. Let's describe the transformation that were applied to this graph. So we have a vertical compression of a half. We have a horizontal translation to the right 4 units. And finally, we have a vertical translation down 5. Okay, we have all of our transformations written out. So now let's go ahead and apply them. So the first thing we apply is the vertical compression. So let's set up our table of values. So the first table is going to be of our base graph. Okay, and let's go ahead and graph that. Now let's apply a vertical compression of a half. So I'm going to take all of the y values from that table of values and multiply them by a half. Okay, so 1/2 times 4 is 2. 1/2 times 1 is 1/2. 1/2 times 0 is 0. 1/2 times 1 is 1/2. 1/2 times 4 is 2. So now let's plot these values on the graph. So -2 and 2. -1.5. 0 and 0. +1.5. And 2 and 2. Okay, so there is our graph with the vertical compression applied. Now we need to move that red graph to the right 4 and down 5. So I'm going to take each point and translate them to the right 4 and down 5. So there's our final graph. Let's state the domain and range. So the domain is going to be x is an element of all real numbers, and the range is going to be any y value that's greater or equal to -5, because we have no points below that y value of -5.